Okay, here we have part two. I went ahead and I solved it out for you because of time, but I want to show you what I did. Okay, first of all, it says from the AP exam, the slope of the tangent line to the curve y squared plus xy plus 1 times 3 equals 0 at the point 2, negative 1. Well, what we did was I went ahead and distributed to 3, so I got y squared plus 3xy plus 3 equals 0. Now, to find the instantaneous slope, we got to determine dy dx. So what we did was did the derivative of y to the second, which is 2y dy over dx, plus, in this case, the derivative of 3x, which is 3xy, and that gives us 3 times y, because derivative of x is just simply 1, and then plus x times dy over dx. Well, the derivative of 3 is 0, and the derivative of 0 is also 0. So we get those. We group the dy over dx's together, and we have 2y and plus 3y. And then we take this 3y that's right here without a dy dx and move it over to the other side. So that way it equals 3y. Well, then we group these two terms with this to get dy dx by itself. So it's going to be negative 3y over 2y plus 3x. And then from there, we plug in this value for x and that value for y, and we get 3/4, which is choice D. All right. Now, to do a little bit more practice, we just kind of did the same thing. Derivative of y to the third is 3y squared times dy dx. Derivative of 2y squared is 2y dy dx. And actually, we had done this problem a little bit earlier in the lesson, but I went ahead and wrote it out again for you so you see it. Now let's look at y to x squared plus y squared equals 9. The derivative of x to the second is 2x dx over dx plus 2y dy over dx equals 0 because the derivative of 9 is just simply 0. Then that becomes 1, and you move it over to the left as negative 2x. So you got 2y dy over dx equals negative 2, which when you move the 2y over to the other side, you get dy over dx equals negative x over y. And then the same thing here, the one in green. Using product rule, derivative of x to the third is 3x squared y cubed plus x to the third 3y squared dy dx minus the derivative of y is just dy over dx, and then the derivative of x is just 1. So then move this term over to the right because we are trying to get all the dy dx's together. That's the thing, we're trying to get all the dy dx's together. And then we get x to the third times 3y squared minus 1 times all times dy dx. And actually, I should probably move this 3, over to the other side. So I'm going to do that. And then I'm just going to erase it right there. All right, there we go. Okay, that's that. Now, the very last one. And on occasion, it's convenient to use logarithms as aid in differentiating non-logarithmic functions. This is called logarithmic differentiation. So we take something complex like this and break it up into the natural log. So I take the natural log of y and the natural log of all this. Well, that equals 2 ln of x minus 2. Remember, the exponent 2 goes out front. Same thing down here. Minus, because it's a fraction, 1/2 ln of x squared plus 1, which then when you take the derivative of ln of y is y prime over y, and then this is just going to be 2 times the ln of 2 times 1 over x minus 2 minus 1/2 times x squared plus 1 on the bottom. Derivative of that is 2x. And then from there, it's just algebra. You do the rest of this is just algebra. So that's all algebra. Okay, that's part 2. You may need to replay this a couple times if you have any questions, or we'll discuss it in class. And I will see you all in class.